All right, boys and girls, welcome, welcome. We are going to get started with assignment 4B. What 4B is dealing with is an assignment that is, uh, it's technically similar to the previous assignment with the scatter plots, as far as we have the scatter plot here. But last time when we did our problem, we made this rough scatter plot, and then the question asked, just draw a line of best fit. And so you just kind of guessed, in essence. You kind of guessed what this line would look like. Through today's assignment, what we're going to do is two different things. One, we are going to get a mathematic perfect line of best fit. So we're going to get an equation of a line. We're going to get an equation of a line. And then we are also going to talk about this correlation coefficient, which in essence tells you, okay, now that you have this perfect line, how perfect is it? Is it exactly perfect, or is it one of those things that you may not want to put much credence into? So that is what we are going to be doing today. So you'll definitely want your formula sheet. You're going to have to be writing down some big time formulas, some of the biggest formulas that I actually know. So let's go ahead and get this party started with question A here. Ultimately, the formula that we're going to be using for this correlation coefficient R, okay, and so here's your formula, and this needs to get on your formula sheet. R is going to be equal to, I'll start with the denominator, n sum x squared minus sum x squared, that's inside of the square root, times n sum y squared minus sum y squared. That's also inside of the square root. And as I said, that's a denominator of n sum xy minus sum x sum y. All right, as I said, that's a monster of a formula. It's a monster. Okay, again, write that on your formula sheet. There's very small possibility that you're going to memorize that right now. Okay, now, if I just had kids try to attempt this as is, it's not going to be too successful. You're not, like a lot of times, it's really hard and you're not going to be very successful with it. So what I've done is I've broken this formula down into three smaller chunks. This top piece, this inside left, and this inside right. And I call these the mini formulas. And I write this kind of down in the central part of the problem. So this is going to be n sum xy minus sum x sum y, n sum x squared minus sum x squared, n sum y squared minus sum y squared. All right, so those are the three mini formulas, and that will make this ultimate formula a lot easier. All right, so again, we're getting kind of on the cusp of what we can probably do outright. But even then, even with these, a lot of times people have a lot of difficulty. So what I do is one more thing, is I create what I call the Christmas tree. And what the Christmas tree is, all these little teeny tiny variables that are in these formulas, I'm going to find all the little variables so I don't have to do any more summations after I create the Christmas tree. You'll see what I mean. So the Christmas tree is n sum x squared, sum y squared, sum xy, then x bar, y bar. This is the Christmas tree. This will get you all of the little pieces necessary to actually be able to construct the mini formulas and ultimately this big correlation coefficient. All right, so here we go. Let's get started. Let's go to our calculator. I have some stuff in here, so I'm going to delete it out. And I'm going to enter my x's. All right. Okay. When you do this, don't mess with the order. So don't put it in order from small to big or anything like that. You're going to mess things up. So just leave it in order. So like, for instance, the 16 matches up with the 2. The 33 matches up with the 3, that sort of thing. All right, so let's go ahead and start getting some of the numbers. So I see n, the grand total number of numbers, or the total number of pairings, I should say, is 6. There are 6 pairings here. Okay, go to my main calculator and I start figuring out the pieces of this Christmas tree. So the first one is the sum of x. The sum of x squared. Sum of y. Sum of y squared. Sum of xy. Then x bar is the average of x. So you add up all the x's, which I did, that's 202, and you divide by the number of numbers, which is 6. And then we also are asked y bar, so you add up all the y's, which we did, that's 28 divided by 6. Okay, now, why did I do the why did I create the Christmas tree? Well, it makes these mini formulas, it makes these mini formulas in the middle a lot easier, So for instance, when I do this very top mini formula, I don't have to when I do this top formula, I don't have to sum anything. I have the numbers. So for instance, what I would write in this top formula is n, which is 6, the sum of xy, which is 1096, minus the sum of x, which is 202, sum of y, which is 28. So I don't have to do any of the fancy footwork. I don't have to use the sum of list 1, list 2, or anything like that. I did all the grunt work already. Or for instance, this bottom formula, n, sum of y squared, minus the sum of y squared. All right, so I'm purely dealing with numbers now with this mini formula, and that makes my world a lot easier. All right, so let's go ahead and get these 3 things. As I was kind of writing here in the blue, I very highly encourage you to write all of these individual pieces in their own unique parentheses. Okay, I really highly encourage that. To write them in their own unique parentheses. So for instance, this top would be n, the xy, minus the x, the y, all in their own unique parentheses. The middle one, n, x squared, minus x squared. Last but not least, ny squared minus y squared. All that's left is to put it into the big formula now. So I have the formula written down. What I'm going to do is I'm going to put my mini formulas in the proper places. So the numerator we see is 920. The inside left is 5,720. And the inside right is 200. All right. Here's how I do this problem, because this denominator can cause some fits, all right? So you can sometimes do it on your calculator, and it's really easy to make a mistake. So here's how I do it. All right, so here's what I do to get this answer. What I first do is I multiply the numbers themselves of the denominator. So 5,720 times 200. Okay, that's what I start this process off with. So 5,720 times 200. Okay, no square roots or anything, and it's going to be a really large number. That's fine. Okay, then what I do with that is I square root that answer. I square root that answer. Okay, that in itself is now the denominator. That is this entire bottom piece. Okay, so all that's left now is to take the numerator and divide by the denominator, which in this case is the answer. Okay, so that's my process on how I get this thing. So it's really easy to mess up that bottom piece. So again, I get the denominator, 5720 times 200, so just straight up multiply the numbers, take the square root of that. Okay, so that's the square root of the pieces multiplied together. Now I take the numerator divided by my denominator. This answer is 100% of the time going to be a number smaller than the number 1. It's always going to be a decimal. Okay, and that's the process. All right, the rest of the stuff is pretty easy. All right, just kind of have to know the formulas and know what you're doing a little bit. All right, X bar, that's straight from the Christmas tree. Y bar, that is also in the Christmas tree. Okay, now these next two questions are asking what is A and what is B. What is A and what is B? Here are the formulas. A is equal to Y bar minus BX bar. So you'll notice to get the A answer, you first need to know what B is. You need the B to get the A. So what we're going to do is we're going to kind of skip over this problem just temporarily and go to question E, which solves for the B. And so B is equal to n sum xy minus sum x sum y, n sum x squared minus sum x squared. No square roots or anything. All right, now I know what you're kind of thinking. You probably are saying, well, Mr. Ashton, I thought you just said that this was going to be easy. What's up with the sums and everything? What's up with this? Well, take a look at the formula of B right here. Look at the formula of B. Okay, look specifically at the numerator and the denominator. So the numerator, for instance. If I flash back to the work that I've already done, It's the very first mini formula written in red. I know what that answer is. It's 920. And the denominator of this is the sum of x squared, et cetera, et cetera. That's that middle mini formula. So again, as I said, I already have these answers. This is 920 and 5,720. Yeah, 920 and 5,720. Cool, cool, cool. So I really don't have to do hardly any math. All I have to do is just a simple division. So it looks scary, but it's really pretty easy. Going backwards to the A formula, all I have to do is pretty much plug and chug. So y bar minus b x bar. Again, use parentheses, and instead of writing this number right here, I use answered because that's the answer that is in my calculator. But I still use parentheses and everything. So this is going to be 4.6667 minus answer 33.6667. Okay, last but not least, excuse me. What is the equation of the least squares line? This function is y hat is equal to a plus bx. And what you're going to do is you're just going to specifically replace the letter A and the letter B with the numbers that you just found. Okay, but everything else, like the y hat stays y hat, the x is still there, et cetera, et cetera. So y hat is equal to A, which is negative 0.7482, plus B, which is 1608x. So your final answer is a formula, and this is technically a formula of a line, and that as I kind of began this whole process, what this equation is, okay, we're given the scatter plot. What this equation is an equation of a line that is mathematically the most perfect that you can get your hands on. It's the equation of that line. The very first question, the correlation coefficient R, 0.8602, is a description of how good that line is. And I'll kind of tell you what that means here in the next couple lessons. But this is a pretty good line. It's pretty accurate. Okay, let's go ahead and do question 2 and kind of streamline the process a little bit. So let's begin by clearing our lists. Okay, so we are going to begin with the Christmas tree. Okay, so I see that there are a grand total of 7 pairs of numbers here. And let's go ahead and get this party started. So we got the sum of x, have the sum of x squared we have the sum of y have the sum of y squared, sum of x, y, x bar, which is the average of x, so you added them up. That was the 44.7 divided by the number of numbers, which is 7. And do the same to y, you added them up, that's negative 17.4, and again, divide by the number of numbers, that's 7. Okay, that's the Christmas tree. Now we go to the mini formulas. Again, these should be on your formula sheet. Write these formulas down. Again, they are very difficult to memorize. It took me a while to memorize these things. So I'm not expecting you to memorize them, but I am expecting you to know them. So write them down. Write them down on your formula sheet. And so, as I said, I already have the numbers of these mini formulas. I just have to, in essence, use them. All right, so this very first one is going to be n, which is 7. Sum of x, y, that's negative 107.18. Again, this is when parentheses are pretty important. Minus x, 44.7. Y, which is negative 17.4. 27.52. Onto the middle one. So we got n, sum of x squared, minus the sum of x squared. Use parentheses. Use parentheses. And then last but not least, the bottom one. So we have n y squared minus y. Again, use parentheses. Use parentheses. Okay. So we have the Christmas tree, which I'm going to try to minimize just a little bit more here. Have the mini formulas. And now I have all the pieces to make my big formula work. So I write down the big formula. I put the numbers in their proper places. Not the right number. I begin by multiplying just the numbers of the denominator, okay? Not the square roots. I don't worry about the square roots just yet, but the numbers of the denominator. So that is going to be 212.86 times 509.94. Okay, so I multiply the numbers of the denominator, and then I square root that answer. Okay, so that is ultimately what the denominator is. Now I take the numerator divided by this denominator, which again, use the answer. Okay, now that is pretty much all the heavy lifting that really needs to kind of be done in this entire problem. We got all the tough stuff done. Now all we get to do is kind of steal our answers and know how to apply things. All right, so the next question is, what is X bar? Well, that's straight from your Christmas tree. What is Y bar? Again, straight from the Christmas tree. We have the next two questions. The first one, what is A? And that's Y bar minus B X bar. Again, we can't get that answer until we get the very next question, which is in essence, what is B? And so B is equal to n sum xy minus sum x sum y. Again, don't be scared. That's just one of the mini formulas. And so is the denominator, n sum x squared minus sum x squared. So we already did the tough part of that. So the numerator is the very first mini formula at 2752. And the denominator is the middle mini formula, which of 212.86. So that is that much, and now all I have to do is just do that simple division. Okay. Back to question A, question D, which is answering A. And this is going to be Y bar minus B X bar. Again, I use parentheses, and I also say that's answered because it is the answer in my calculator. So negative 2.4857 minus answer of 6.3857. Last but not least is to consolidate these two answers into one function, one formula. And so this equation is y hat is equal to a plus bx. And all I do is replace the letter A and the letter B. So the letter A was 3.3113 plus B x. That's it. Again, this is the equation of that perfect line of best fit, or least squares line, things like that. All right.